All right, welcome back. Now what we're going to do is we are going to now take the next step in our study of linear algebra. So this is titled Maps Between Spaces, and we're going to start with isomorphisms, and of course always start with definitions and examples. Now before we jump in with some examples, I want to reiterate or go over some things, or a couple of things that we had talked about before. Remember when we talked about different spaces or different different vector spaces, and we said, hey, these are quote unquote the same, or we have this intuition that they're the same, right? And we kept using this air quotes, right, for the same. And even though they weren't the same, right, if we took two tall vectors and we compared it to two wide row vectors, those are obviously not the same, but we feel that in some way that they are quote unquote the same in certain aspects. For example, we also looked at linear systems, right? We started out with an investigation of linear systems, and that led us to this other thing where we found that these linear combinations were closed, right, under certain operations, and we then found that, hey, under certain circumstances, we labeled these collections of all these linear combinations as a vector space. And then, now that wasn't the end be all, right? That led us to understanding what a basis is, right? So we're going to do the same thing going on now as we take the next step in our study of vector spaces, and we're going to see how, hey, what's the relationship there? What do we mean by the same? We're going to now be more precise in our language, and we're going to spell that out more precisely, is I guess what I want to say. So anyway, that's where we're going to start, and we're going to start with a couple of examples to get the ball rolling, and then we're off to the races.